Okay, so the first speaker after the small break is Hinek, and I had a little trouble pronunciating his name, and he's an infrastructure programmer in a small ISP in Germany, and also a Twisted contributor, and he will talk about developing solid application deployments for everybody. Thank you.
You can read. Good to go?
Yeah.
Okay. So it's a small room. I assume everybody can hear me okay? Awesome. So thanks that so many came again. Since this talk has been already brought to PyCon and it was similarly full. So you're all here because you realize that Borat is right. Programming is fun. Deploying the results is agonizing pain. And in my experience, most of this pain comes from a lack of orientation. And I'm here to take some of the pain from you. Good morning. I'm Hinek. In real life, on Twitter and all over the interwebs, I work, as Michelle already told you, in a small ISP. We sell LAMP-based web hosting, mail services, sell domain, stuff like that, and we proudly serve the PyLadies web page. The reason I'm telling you that is to give you some context, because our systems are probably different from yours. We don't have one big Django application, which everything evolves around, but we have many small systems. Most of them are written in Python, and the types range from small monitoring scripts with Pynagios till full-blown pyramid and twisted applications. And yeah, it's pretty important to us that everything works pretty reliably, because there's not that many people in tech with us, so I don't have the time to babysit all of the applications. And there's several dozens of them, so this is the context I'm coming from. So, enough about me, what's on the agenda. It's going to be a whirlwind, because all I have are 45 minutes, and I hope to replace the lingering anxiety in you with an informing annoyance, and that will be good enough for me. So, it's also going to be a whirlwind in a sense. It's going to be really fast-paced, and in order to pull it off, I've set up a page for you with all the links, all the concepts, and the slides, so you can study it later, so you don't have to write down links here. So I will be not presenting any links. And I will show the link at the end again, so don't sweat it. It's also going to be an opinionated talk. That's also the reason why I gave the context. Your circumstances are probably different from mine. So there are valid alternatives to everything I will tell you. And use your best judgment to decide whether my solutions fit your problems. What I won't be talking about is platform as a service, because it's their job to deploy, and most of the time they are different anyway. And I won't be talking about schema migrations, which for some reason is the favorite question I get asked every single time I'm talking about deployments. The problem with schema migrations are hard. I can't give you a simple solution to that. You have to do it case to case. So, what will I be talking about? I will take you through a complete cycle from development to production, how I consider it responsible, and I will point out a few popular mistakes around the way. Yeah, that's all. It's still a lot. But still, I would like to take a step back and introduce you to the key concept behind everything I will be preaching today, and that's easy does not equal simple. Easy is something you know already, or something that lies near. It's the opposite of difficult. Difficult is annoying, but it's not really a problem. It's what we get paid for, to solve difficult problems. Simple, on the other hand, is the opposite of complex. And complexity is evil. You want to get rid of complexity as much as possible. And don't take my word for it. Let's ask trustworthy, witty old guy, and who's more apt than Dijkstra. Simplicity is prerequisite for reliability. And anybody who has been phoned at 4 a.m. out of his bed knows that reliability is what you want when it comes to operations. So, I guess easy solutions are those you already know. Simple are the ones you have to search for, actively do your research. But they are worth it. And I have another trustworthy old guy to back this argument. It's Donald. It is important to find simple solutions instead of stopping as soon as first solution is found. This is kind of important because that's what most people do. They just find something that works somewhat and stay with it. So the corollary is put effort into making your deployments simple. And it doesn't have to mean that you have to copy my style of deploying applications. It means that you have to look at your context and decide how to get rid of all complexity.
Amen.
So, you've got an awesome idea for a Python application. Maybe you have already even a working proof of concept. How do you bring it into production? The first decisions to make are before you're writing a single line of code actually, because on what platform are you going to develop your application? So we run our applications on Linux. There's no way I will ever run Linux on my desktop again. I did it for a decade, don't hate me, but I won't do it again. On the other hand, if you test your application on anything different than your target platform, you will run into problems. Because packages and Python itself behave in often perfidiously subtle different ways on different platforms. So, does it mean you can't use your shiny Dell notebooks for the Windows 8? No. Fortunately, there's virtualization and there's Vagrant, which makes it not a pain in the butt to use. I can do it justice here, but it's just a way of automatically managing virtual machines. And yeah, one of the main features is just it helps you to set up a sane development environment, including file sharing. So you just develop in the full comfort of your development environment, PyCharm, whatever. And the files get automatically mirrored into the VM where you can run your tests, where you can run your development server, stuff like that. It's awesome. Especially if you're a freelancer who's working with a lot of clients, you should have a look into it because it's made for you. It's made so you can easily swap out various environments and define them in a programmatical way. So, the ops crowd told you that you're going to deploy on a super stable CentOS 5 because they hate you. And who knows which Python comes with CentOS 5? Right, 2.4. I think I've saw people who are younger at this conference than Python 2.4. So, does it mean you have to use it? No. I say no to ancient Python versions. And because you're arbitrarily trading everyday productivity for the effort it takes to build a system package, or just to Google it for that matter, because there are Python 2.7 builds for every platform out there. You just have to look for them. But again, don't take my word for it. Let's ask the author of one of the most popular Python packages and what he had to say to someone who was complaining that requests doesn't work on CentOS 5. Python 2.4 is not supported. It came out 8 years ago. It's already on YouTube. Upgrade. And I think we are nearing a decade by now, so it's even an old comment. So I have nothing to add. If you are making money with Python, it becomes your key infrastructure. And a key infrastructure should not be bound to a third party or even a version of a product of a third party. And that it's not about having the latest shiny too. It's about being in control, because what if one of your crucial applications does run Python 2.4? Are you going to keep a single CentOS 5 server around to just accommodate it? The ops people will hate you even more. So I hope you get it, but your boss won't let you use adequate tools because of enterprise policies. It's your call if it's worth it. So for me, it would be worth it if I could realistically cure cancer or something like that. But otherwise, I think there are several recruiting sessions at EuroPython, so don't settle for bullshit. What now? Do write code, do write tests. Simple like that. Do write tests. Strive for 100% line coverage. So some obscure typo in an obscure branch doesn't bring your app down. I know this is preaching. You should try to achieve it. If you don't, the problem is, however, that tests, no matter how much line coverage you have, are worthless if they run against a different set of dependencies than they run in production. So you may be tempted now to just use the packages that come with your distribution, the Python libraries, because well, there you have your version parity, right? unless you write software for a distribution, never ever use libraries from a distribution. And unless you can guarantee that your server will run only one Python application, don't use global packages at all. First, what's wrong with system packages? They are spotty. So you're either cut off of valuable tools from PyPI, or on the other hand, you end up with a clusterfuck of self-installed packages and system packages. That's complexity right there. They're outdated. I mean, do you really want to use Django 1.3 until the next Ubuntu LTS? But on the other hand, it works in both directions. Again, do you really want to dread the next Linux release because operations will upgrade your servers and your Django and the Django package will be upgraded, whether you like it or not? You lose control over your own development cycles. That's a very bad thing. You don't need another moving part which you have no control over. Quick word about global packages. You can get away with them if you have one virtual machine per application, which is kind of more realistic by now. Now we have the rise of LXC. Otherwise, don't do it. It's enough to have one package which is conflicting between them. You have to start thinking again which applications don't have conflicting dependencies. You don't want to have to think about that. And you don't have to because we have virtual environments. There's nothing, I just assume you know what virtual environments are. Just use them consequently. Just get one virtual environment for an app, install your dependencies, run your tests, and when everything's done, freeze your requirements, and the whole known and proven to work environment is just in pip install-r away. One word of caution, don't rely on semantic versioning. It's well-intentioned, but it doesn't work. It will bite you. Always pin them hard. And when I mean it will bite you, it will really bite you. It bites everybody. Some people just do something like they will allow the minor version to raise and stuff like that, which is supposedly non-breaking updates, but yeah, there will come a breaking update which shouldn't happen. By now we have some alternatives to keep your virtual environments up to date, and that is pip-tool from Winston Dreesen, and pip gained a new option, piplist-o, which will show you outdated packages too. So you're kind of convinced, but you were hesitant because you want Red Hat or Debian make sure that you can't get hacked. That's the most common objection that came up when I released my blog post about this actually, and it's kind of BS and it makes me mad. So it's your job to make sure that your software is secure. It's simple like that. Your customers won't care at all that your vendor was too slow to patch a 0-day in your web framework, and that's the reason why the credit card data is on the internet. Remember the Rails vulnerabilities where they were supposed to be applied like immediately? So waiting for your vendor to fix them for you is irresponsible. You have to take responsibility for your applications. So we have an interpreter. We have well-tested code, hopefully. We have known to work dependencies. What's next? We've got to get it on the servers somehow. And it's my humble opinion that it should have as little moving parts as possible. So, and ironically, the most favorite common way to do that is apparently just using Fabric and git pull on all the servers, which is quite the opposite. And so I say, nah, there's a better way. But I'm not hating on Fabric here. I love Fabric. And I use it for my deployments too, but not like this. What's wrong? I don't want build tools on my production servers. I want my production servers to be as minimal as possible. That has two advantages. First, they are faster to get set up. And second, every piece of software is a attack surface. Every piece of software installed can and will be used against you. So have as little code on your servers as possible. And, well, as soon as you start to deploy to multiple servers, it gets repetitive. So you want to upgrade some Django application. Now you have to upgrade all the virtual environments or on all the servers. You have to download the dependencies on all the servers. Which you should just have. We have a nice private PyPI software now from Holger Krekel I'd like to give a shout out called DevPy. it got much easier to have private PyPI servers, so you should definitely have them. Because didn't we have a PyPI outage just yesterday or something like that? You don't want to rely on external services when it comes to deployments. Because again, if you have some important update to make, it's rather bad for you that you can't deploy your application because PyPI is down. So, yeah, that's about it. So what I like is to have a package which is self-contained, which contains everything that's needed to run the code or to run the application, and nothing on the target production server is required to make it work. And I wanted to be able to deploy it to an arbitrary number of servers. And guess what? We have something like that. It's called native packages. And it doesn't matter whether Deps or RPMs or whatever, they just work. They work for several decades now. So what's nice about them? They offer introspection. You can query your servers which version is installed. You have nice CM integration, as in configuration management. So you can define your servers that this server has this version of this package. No matter what's the newest one or the oldest one, you just want this version. And they're versatile. You have various shell scripts and hooks which will, are run when you install the software. So, how does it work? It's actually pretty easy. You have a build server of the target platform, and it's important that it's the target platform. Because as soon as you're using binary packages like psychopg or something like that, they can be incompatible between the two. For example, you couldn't, from generic to precise, the compiled binaries didn't work because of some changes in the glibc. So the build server has to be identical to the production server. There you create your virtual environment. You install your dependencies just like shown on the slide before. You do whatever you want with the final state of your application. You package the result and you push it to your repo, and then you can install it whenever you want. And I really like step 4 because at this point you have the application in the final stage. So what can you do? You can run tests, and if they fail, no package for you, loser. You can compile your static assets. So if you have less, SASS, CoffeeScri, all this stuff, you can compile it before you deploy. You don't need some Django extensions to compile your SASS scripts. You can compress your assets, something like YUI compressor, and gzip it for all I care. You can add cache busting tags to your templates. You can do whatever you want because the application is ready. And then you deploy it to as many servers as you want, and they don't need to have a SASS compiler or a less. I think less is based on Node.js, stuff like I don't want to have the production servers. So I hope you're kind of convinced, but you think that packaging is hard, which fortunately is not true anymore. For Jordan, Syslo gave us FPM and it was good. Actually, it's easier to use than tar. You give it the source type, which is in this case a directory, a target type, a Debian, and a directory. And there is your dep or your RPM, whatever floats your boat. It supports basically everything. It's that easy. So you don't want to run a repo server, then don't. Because you can install packages on a command line or just use plain tarballs. That works fine too. I'm not trying to convince you to use native packages per se. I'm trying to convince you to package ready to run applications which can be put on a server and work. How you achieve that is your thing. You can start packaging LXC containers for all I care. So what you want is to automate though, because if it's hard to do, you won't be doing it, or you will be deploying less because you want to just not do the effort, or you will start to looking for loopholes. So secretly run your git pull on target servers to just get this one little patch in. So that's basic human psychology. We can't do anything about it. So that's why it's important to put the effort in the front and make it easy. And I show you what I have to do to deploy a Python application. This is all. This is a YAML file where I define the name of the application, which is used throughout the script. A project, which is just an artifact from git stash, which we use, Atlassian stash, which we use as our git front end. The Debian build dependencies, in this case, that's the Postgres development libraries. and the run dependencies. Again, I don't have to install the build dependencies on my target servers. And to stress once more, these are Debian or Ubuntu dependencies, not Python dependencies. The Python dependencies are installed using pip install-r. And this is all. I have no reason to look for loopholes. And this is what you want it to be. You want the correct way to be the easy one. All I do now is just type in deploy, and it starts building. So, and the code behind that, it's pretty trivial. I think there isn't even a for loop or something like that. It's just a few ifs. But it's highly specific because I don't want to have boilerplate here all over the place. But I've shared some of the code on my my blog post on deployment with native packages, which I'm updating all the time. So if you've read it a few months ago, I've updated it because I used to use a Fabric script to do it programmatically. But I thought it might be a better way, so now I've arrived here. So yeah, the link is, as usual, in the resources. So obviously there's more than one way to do it. There's even more than one correct way to do it. And for example, Dan Bravener wrote a retort to my blog posts describing how they deploy using Git and Fabric, which for my taste is still too many moving parts, but maybe it fits your development and overall style better, so check it out. So, what next? Configuration. What do we do about that? Let's put it to the package too, right? It's convenient. Use a configuration management system. It's a declarative way to describe your systems. So you don't describe how you get to the goal, you describe the end goal, which, for example, in the case of a Whois server could be, this VM is a Whois server. This means that the package Whois is installed and that the configuration file etc whois.ini is in etc with permission 600, and the CM chooses the path. There are a lot of solutions to that by now. Unfortunately, the most common ones nowadays are Puppet and Chef, which those configuration languages terribly reek of Ruby. But the Python-based are catching up actually. So Salt and Ansible, especially Ansible, which seems to have got a lot of traction lately. So we are even considering to move from Puppet to Ansible. So if anyone has experience with wrangling more than a handful of servers using Ansible, maybe could talk to us because we have a few questions. So, despite all that, it's kind of the poster child of easy versus simple, because none of them is easy at all in the beginning. You have to plan ahead, and if you've never done it, it's pretty frustrating because it will take several attempts to get there. So why use them anyway? First of all, the obvious way, the reason is safety and security. I feel better when I'm running my test, which contains stuff like drop table, when I know that the configuration for the production database is nowhere near my source code. And there are also practical reasons. For example, imagine you just fired someone, and you can try to remove their SSH key from every single server, but I guarantee you, if you have more than 3 servers, you will forget one. So that's where CM comes in. You just tell that you don't want this key on any server, and it will make sure that it happens. The main point is reproducibility, though. If you get mentioned on TechCrunch, or one of your backends dies, you don't want it to take more than a few minutes to have a new backend up and running. Unfortunately, most of it is delayed gratification, which people are very bad at, us included. But I can only urge you to do it right from the beginning, because we had to puppetize an infrastructure which was running for 10 years, and it was a rough trip I wish to nobody. So, reproducibility, it comes handy when it comes to staging, because you don't want to just bring your application into production environment. You have to test first that it really works in production environment. And that's where staging and CM come in again. You use it to set up an exact replica of your production environment, but the only difference is what you are trying to deploy now. And then you can run your acceptance tests or see if it installs at all. So we have code, configuration, and yeah, what next? the application is listening on port 80 or it's doing any rooty stuff. So the application itself has to run as root 2, right? So one last declaration of love. I love root. Sudo is for jerks to make other people make sandwiches. But when it comes to network-facing applications, 9. Don't do this. The internet is full of people without a life or with a significant income from intruding into systems, into your systems. And when they find a Rails-grade 0-day in Django, which they will eventually, so just a matter of time, you don't want them to own the whole server and start sniffing your local traffic. It's very bad. So if you need to listen on the privileged ports, and if you are doing web development, chances are that you don't. But if you do, drop privileges after listening, or even better, use the aforementioned outbind tool, which allows unprivileged processes to listen on privileged ports without having any special privileges at all. If you need to do something rooty on a server, like creating users, deleting users, stuff like that, write single-purpose workers and interface those from your network-facing application. And we have a lot of solutions to that, like Celery, RQ, ZeroRPC, or if you're working with Twisted, there are 2 built right in called Perspective Broker and AMP. Because you want the privileged code to be as small as possible so you can reason about its security. Yeah. So, a healthy paranoia doesn't end with not running your application as rooted though, because they are out there to get you. So, let every app have its own user with bin false as a login shell. Use packet filters to lock down all the ports as tight as you can. Do you recall the Postgres vulnerability a few months ago? This is what happens when you rely on application security. We didn't really care because our database ports are locked down for exactly these reasons. So reject everything except you. Use file sockets for intra-host communication. They are faster, they are more secure, and you can stop coming up with port numbers all the time. Avoid shared databases. If you can't, lock them down as good as possible. So again, one app is one user, and this user has only as much power as it needs. You can lock it down. In Postgres, you can lock it down to schemas, tables, or even columns. Use SSL for everything. We use SSL even on our private networks because you never know if some obscure server gets hacked for some reason and people start sniffing their way to your database. And finally, use some kind of fail to ban, which basically just blocks client IPs which are trying to brute force their way on your server. Sadly, that happens much more often than you think. So, now you've set up your staging box, installed the package, CM put a configuration in place, and created a dedicated user. Now you SSH on the host, start up a screen, and run the server so you can detach from it and log out, right? Show of hands, who has ever done that? Oh, come on, don't be shy, we have friends around here. Look, Spotify did it. So, and as your friend, I have to tell you, don't do it. It's stupid. You probably knew it's stupid. I knew it's stupid. But one does it anyway because it was easy. And first of all, you totally should use tmux and not screen. And even that is wrong. Nowadays, we have great alternatives to get your application up and running. The sad days of writing init 5 scripts are long forgone. So we are running Ubuntu. So we use upstart, which works well enough for us. And I'll show you how much work it is to define an upstart job for a Django application. This is all. You say that it's supposed to start once the network is up, stop when the network is gone, respawn on crash, run from a certain directory as a specific user, and that's all. You can just type start your app, stop your app, reload your app, restart your app. It's that simple. No shell scripts anymore. So, while I'm at it, one little diversion into logs. People get frustrated by Python's logging, and I got too recently because the whole idea was it to make the default action if you log and didn't configure logging to just do nothing. I find it very hostile API. So I try to avoid using Python logging as much as possible. So I configure it to go to stderr, then use a Python container to catch whatever is coming out from stderr and stdout and redirect it to syslog, and then use OS tools. The only catch is that it is possible to overwhelm syslog. But if you have such problems, you're not sitting in this talk. So, yeah, and we have proven OS tools. We don't need to configure a Python application to do the log rotation and stuff like that. And as somebody who used Django, Pyramid, and Twisted, and every single one of them has to be configured in a slightly different way, I just prefer simplicity. And how much work is it? This is how it's for MicroVSG. It's this one line of configuration. Twisty is 2 options, and in both cases your audio log entries get tagged with the name of your app, which means you can use this tag. For example, this is from rsyslog to get your application-specific log file. And again, you don't have to care about logging inside of your app at all anymore. You just configure it to use the standard error handler, and then everything else is just done by the proven tools. And the ops people will love you too, because that's these are the tools that are used for everything. There's no reason to have a special cake just for Python applications. So, at this point, you may have realized that Django's web development server is not web scale. So, for web applications, you will need a Whiskey container. And it's well known that the only true answer to that is Apache and mod Whiskey. Yet, comrades. Another disclaimer, it is perfectly valid, and there are perfectly valid reasons for using Apache. But you should know those reasons and not use it just because you've heard of it and it's the only thing you've heard of it, or of ever. Because, you see, maybe you need a fully fledged attack helicopter with the added feature of Python hosting. But what if you don't need those rockets? And you can take them off. You can strip Apache down pretty well. But it's my personal preference to work up, not down. So I keep adding features or configurations until it does just enough, not take a big ball of mud and start stripping everything away what I suppose we'll never use. So, in my opinion, a combination of a lightweight Whiskey container like MicroVSG or Gunicorn together with Nginx gives you a much better separation of concerns. Your application does its app magic and nothing else. And Nginx takes care of stuff like HTTPS or redirects to HTTPS. And it can perfectly serve your static files like JavaScript, images, stuff like that. And it even has some get-to-load balancing built in, so you can get away with that too before you immerse yourself into HA proxy. And this modular approach also has the big benefit that you can test both sides independently, which is a very good thing too. So let's look how much effort it is to start a single worker using Gunicorn. This is all. IRC is full of people sad that they can't get Apache to do what they want. This would have been enough to get them started. And Nginx, you can make it even easier by configuring Django to use Gunicorn by default, and you can use just manage py run Gunicorn. And Nginx is just as simple. This configuration gives you, it will forward all web traffic from to this Unix socket, which your app is supposedly listening on, and everything that's from static will be served directly from a different directory. This is all it takes. So, this was easy and good. Let's take the leap to awesome. MicroVSG is overwhelming, and I wonder if there's any mortal on Earth who can fully understand it. And I suspect if such a person exists, he's sitting in this room. But the implication is that the best features are often overlooked. So I talk with people about MicroVSG and they're just, what? It does this too? And what I really like is the Emperor mode, which, this is Empress by the way. It was originally made for multi-app deployment, but it gives you seamless app reloads by touching a configuration file. which is pretty awesome. So you get your reload, but you don't lose requests. And it's still just as easy, actually. So you tell MicroBSG to run in Emperor mode, you configure it to watch this one configuration, and that's it. Whenever configuration management touches production.ini, it will be restarted gracefully. Or if you do it. I do it in my post when I deploy a new version. I check whether the application is running already, and if it's running, I just touch the configuration file, and I know it will be reloaded seamlessly. And we've also switched to the MicroBSG protocol, which is slightly more performant than just sending around HTTP or general BSG. And yeah, this is how you configure Nginx. You have sometimes to put more MicroBSG params inside, but that's just a matter of Googling and reading docs. It's really easy, and it's a joy to use. So, here we go. I think we have everything. Your acceptance test in staging passed. Awesome, you bump the version in the CM for the production servers. You trigger a CM on the production servers, and done. Except when not. So, what happens now? Unless you had a database migration as part of this deployment, in which case you should start sweating now, it's pretty easy to roll back. You just decrease the version in the CM again and investigate what went wrong. You have to plan for failure, because failure occurs no matter how much effort you put into it, even for NASA. So, and see what happened here. The actual deployment is actually easy. And that's what you want it to be, because it's the only point where it affects your customer. So you want it to be fast. Ideally, not losing any requests. We've achieved that. You want it to be predictable. You always want to know what's happening now. What's the state of my systems? What will I do next? And easily reversible. And that's a major point, because being able to roll back a failed deployment without fiddling on a target servers is a sign of major deployment practices. So, your application is in production and up. You need to know when it's down. And how do you know when it's down? It's with monitoring. And it's not just about front-facing application either. So you all hopefully do backups. But do you also check those backups that they're succeeded and that they are actually usable? And remember the SSH key of our ex-coworker? If you don't monitor your CM on all your servers that is doing its job, you can't rely either that the SSH key has really been removed. So, the easiest way to get in monitoring is ping them. You can sign up and just start adding tests. It's really easy. You have HTTP, HTTPS, DNS, SMTP, POP3, and IMAP built right in. But it's usually not enough. It's a nice start. But for example, we need to monitor internal networks too. So at that point you arrive at something like the venerable Nagios, or in this case it's Shining Fork Ichinga, which is what we use. We use Ichinga for everything, plus some basic tests in Nagios, in Pingdom to make sure that our routing is working well. And yeah, and make sure that your notification settings make sense, because it's not very useful to find out that your mail server is down and then try to use it to send your notification email. So, knowing that your app is down is not enough though. To be a true master of your app and captain of your uptime, you have to know what the app is doing right now. In order to predict problems, you have to be able to look into your systems and know what's happening. And again, there's a pretty easy and pretty solution called vibrator metrics. It gets a bit pricey though at some point, and I find it a bit wasteful to send HTTPS requests all the time over the internet. So at some point you will probably arrive at statsd and graphite. Statsd is a pure aggregator. You just throw UDP data at it, and it gets it does some math magic to it, and forwards it to graphite, which will give you storage and a rich graphing API, which is by far not as pretty as Libretto. I should say that there are ways to integrate std with librettos, so the sending HTTPS over the internet is not the real reason. But yeah, the point is you should really collect a lot of metrics. Basically all of them. Every metric you can. And that's like users logged in, users online, mails sent, mails received. Very important, request durations. So you can see if you have any anomaly in your response times. Stuff like that. And you need to know all this stuff to make informed decisions about the future of your development. And these are the tools that will tell you just that. And thus, armed with the detailed knowledge of the state of your application, you return to the fun and games part, programming. So, you've made it to the end. Here's the link to the annotated link list again. I encourage you to follow me on Twitter, read my blog, and if you speak German, you could get your domains at Viromedia. For their generosity is the only reason I'm standing here. Thank you, and see you at the REVO bar.